Hey Algebra 2, welcome back. We're looking now at chapter 7.3, Logarithmic Functions, equations or whatnot. And here in front of us is a set of notes. Okay, very valuable, incredibly valuable for this section. So let's kind of discuss this. Okay, the first thing that you need to know in connection with yesterday's lesson about inverses is that an exponential equation has an inverse that becomes a logarithmic equation, and the same situation applies with a logarithmic equation who happens to have an inverse equation by name exponential equation. Okay, so most of you guys are comfortable with the exponential equations. Okay, some numbers b raised to the x equals a, so I'm going to call this base b raised to the x equals some value a. If you wanted to turn that into a logarithmic equation, then you would take log base b, right? I called it base b here, so here log base b of some value a, all right, goes there, and it'll equal x, the exponent. Okay? So the other thing I want to mention is this criteria that must be met is that b is bigger than 0, but b cannot equal 1. So the question is, why not just say b is bigger than 1? Because there's numbers that are bigger than 0, but right, positive numbers, but not equal to 1, namely 0.5, 0.75, those decimals in between. Okay, so this is important. Anyways, moving forward, let's go and look at an example. So they want me to evaluate this logarithm. Now, because I'm not comfortable, and many of you guys are probably not, I want to go and apply this knowledge that I just looked at, okay, in terms of notes. So it basically said that if I have some base b raised to an exponent x, I would get some value a. All right. The connection with that is that I can turn it into a logarithm by introducing a base b of what? Do you guys remember? You can pause the video and ask yourself what goes here. Okay, what goes here is the value a, and on this side goes the exponent x. Right? So essentially, what they're asking me here is log base 4 of 4096 equals some exponent. So since this is difficult, I'm going to come back and I'm going to convert it into an exponential equation. But I got to be careful, right? I need the base, which is 4. Right? Then after that, the exponent is x equals what? 4096. Right? So essentially, it's simply asking me, hey, 4 to what power gives me 4096? So we can toy with the calculator. I'm sure there's other methods. We'll go the most generic possible. We'll go to calculate, and I don't think 4 to the first would work. That's 4 to the second is 16 to the third is 64. So let me try 4 to the fourth. See what that gives me. Okay, it's closer but not close enough. 4 raised to the fifth. Getting closer, and then 4 raised to the 6th is 4096. So then x is equal to 6. And that's how one approach to evaluating this logarithm. Okay. Alright, next, write the exponential equation 2 cubed equals 8 in logarithmic form. Right? Now, because practice makes perfect, I'm going to rewrite what was introduced in the notes at the very beginning. So basically, base b raised to some exponent x should give me some value a. And in terms of converting to a logarithm, I'm going to have log base b of some value a equals x, the exponent. Okay. So with that said, they want me to, and again, I'm suggesting that you guys write this over and over because it might be simple at the moment, but trust me, this stuff can get really confusing after a couple of days break, okay, or as you're learning something new. Anyways, so take this exponential equation, turn it to logarithm. So I have 2 cubed equals 8. So for me to do that, I simply introduce the log. I need base b, which is 2, of what? The value, which is the 8, which equals the exponent 3. Alright? A quick way to check this, alright, is check this out. I'll use a different color. This works for me all the time when I need to do a quick check. I say 2 raised to the third exponent, which is basically 2 cubed, should equal 8. Okay, this little cycle works for me. It's a quick way of checking. Let's see if that will work for you guys. Okay, try that out. Alright, write the logarithmic equation in exponential form. So they want us to go in the other order. So once again, what I'm going to do here is, since I'm getting really good at this, I'm going to go base b raised to x to the some exponent x gives me a value of a, and the conversion of log base b of some value a produces that exponent x. Now since I'm having to work from logarithm to exponential, I'm going to switch the order. Log base b of some value a equals x can be converted to base b raised to exponent x equals a. So now I can use this form. I'm going to plug this one in. Log base 4 of 16 equals 2. And since this is the base, I'm going to put a 4. I now need x, which is a 2, so I'll put it up here. It should equal to 16. And what do you know? It checks out. Very true. Okay. This doesn't really need a elaborate check or additional check beyond what you guys already know, because 4 squared does indeed equal 16. And let's take a look at this one. Evaluate log base 4 of 1/16 by using mental math. Alright, at this moment, you can follow the same logic or process that we've just recently introduced, right? Log base b of some value a equals what? The exponent x. Let's see here, which would be what? Base b some exponent x equals a. Right? You can use this method to solve it, but really what they want you to do, I'll do a page break, they want you to start thinking of, hey, 4, right, since they don't have equals to something, evaluate means they need that exponent. So 4 raised to some exponent should give me 1/16. Okay. If you're not great at negative exponents, the next example will be right up your alley. But at this point, after you play with some numbers, you'd come to terms that, hey, if you put in a -2, you indeed get this answer. Okay. So that's all, the whole process behind the mental math. Now, if this is a little out there for you, then go and follow this same process. But again, this is what they're hoping and aiming for with you guys. Right? All right, let's go and move on to this next one. This one's got a lot going on, but it's going to help us work with these negative exponents and see kind of what they do. Refresh your memory, because I'm sure you've done that since Algebra 1, and we've looked at some of that in Algebra 2. Okay. All right. So use these x's to graph this function, then graph its inverse. Excuse me. Describe the domain and range of the inverse. All right. So they want these specific x's and graph the function. So like most of us, although it says to do this, many of us would just punch in the calculator out of curiosity, see what it looks like. So let's go and start off there, right? F of x equals 2 raised to exponent x. Let's go back home. Let's go to graph. Okay, not sure what's going on there, so what I'll do is I'll start a new document here. Okay, graph. So 2 raised to the x. Alright. Now from here, what I'm going to do is I'm going to capture an image to save me time here and having to redraw it. Much less accurate, by the way. Okay. Alright. Okay. Alright. So they do want us to graph, so just to be honest here, let's go ahead and pretend that we're starting from scratch. So here's the x's for, we're talking about f of x. Alright. We'll put a little colon there. So let's go ahead and map this. Alright, so here's my x values. -3, -2. Oops, there's no -1, so I'll go 0, 1, and 2. Alright, now you can go plug this, again, since it's 2 to the x, these are all your x values, so the first one is 2 to the -3. Now to save time, and because I know the answers, I'm doing the mental math, I'll just jot them on here, but you can take time and put 2 to the -3 and hit the calculator, and I'll give you these kinds of values. Okay, this one is 1/4. Anything to 0 power is 1, 2 to the first is 2, and 2 to the second is 4. Alright, so let's go ahead and map these on here. -3, 1, 2, 3, -3. Should be about 1/8. It looks like it's right on the x-axis, but it's not. 1/4 is a little higher. They didn't do 1. They put 0, 1. They put 1, 2. And 2, 4. 2, 4. Okay. So the whole point of this is just to show you that what the calculator produced is indeed consistent with our table here. Okay. Alright, so we've got that. Then it says graph the inverse. Inverse. Okay, don't forget what we learned yesterday. You guys know something in particular about the relationship, right? A function and its inverse, an equation and its inverse is what? Okay, let me go ahead and set this up here. The problem we looked at yesterday was a relation, but the same applies here. Okay. Is if we were to, okay, many of us don't know, right? F of x here was 2 raised to the x. Many of us aren't super comfortable yet, but what this one would look like, the inverse at least, would be log base 2 of x. Okay? Now, before we get all caught up in the calculator and the functions and the keys, you guys have this prior knowledge that'll bail you out real quick by doing what? Okay? If you said switch the values, you're correct. So all these are now y's. -2, 0, 1, and 2, and this 1/8, 1/4, 1, 2, and 4. Okay, we'll go in this table right there. So it says graph the inverse. So now I can go to town here, right? At 1/8, I have -3. Okay, 1, 2, 3. So very close there. At 1/4, -2. Okay, so about there. Okay, and then at 1, 0. 1, 0. Then 2, 1. 2, 1. And then at 4, 2. 1, 2, 3, 4. 1. Okay, so if I connect this one. Okay. Yowza. You'll see something pretty special, which is again from yesterday's lesson about inverse functions, is that what? They have that reflection off of the imaginary line y equals x. Okay, so it still exists there. We've accomplished this mission, we've graphed it, and now finally they want us to describe the domain in range of the inverse alone. So let's go and do that here. Okay, so I'm going to go ahead and write the domain of the inverse. I'll introduce that little -1 there up there, is a set of all x's such that what? They're all bigger than what? Let's take a look at the graph here. Okay, the x's. Alright, you'll notice that they get close to this line but never pass it, so they're definitely all bigger than 0. So that's what I'm going to say here, is that all the x's are bigger than 0. In terms of the range for the inverse, is a set of all y's such that, what about the y's? Whoops, I jumped the gun there. Let's take a look at the y's. What can we say about the y's? Well, they seem to go up forever and down forever, so we can say that y is the element of all reals basically that there's no restriction. Guys, thanks for your time. I'll see you tomorrow in class with questions, comments, and concerns.